Good morning. Time for science. I'm going to go through this fairly quickly so it doesn't take too long for you. After I finish this video, I'm going to insert it here at the beginning of the quiz. So that's what you will watch first when you open up the quiz. My going through this with you to give you some extra help. Once you've listened to that, there's another video for you to watch introducing the concepts again, after I've been through it as well, of reversible and irreversible changes. Then after the video, where you've got some visual support to help you understand, I've then included some written pages here for you as well. So let's go through these together. Reversible changes. Now this means a change that can turn back again. It's not forever. So for example, if a material like, let me see, an ice lolly, right? You put an ice lolly in the freezer to turn it into a solid ice lolly, but you could take it out of the freezer, leave it somewhere warm, and it would melt and turn into liquid. But you could change that, you could reverse it. You could put that liquid back in the freezer and turn it into a solid again. So you can reverse the change. So it can be changed back to its original form. Two examples are exactly the one I just gave now, freezing and then heating it to turn it back into a liquid. Then you could freeze it again, turn it back into a solid. So you've got a solid orange lollipop and a liquid orange drink, but you can freeze or heat up again to keep changing it. Melting is another one. If you've got a bar of chocolate, this is a reversible change because you can heat it to melt it to turn it into liquid chocolate, and then you can cool it to turn it back into a solid. It's reversible. You can change it back. Evaporating and condensing, which we've done a lot about, are also reversible changes. So you can take a puddle of water here, evaporate it, the heat of the sun, for example, and it will turn into water vapor. But then you can take that water vapor, cool it on some glass or a piece of mirror, and it will condense and turn back into a liquid. You can take that liquid, evaporate it, it'll turn to water vapor, take the water vapor, condense it, turn back into it. So you can keep changing. You can reverse it. It's reversible. Two more examples are dissolving and mixing, which we've also covered a lot in our topic so far. So when you dissolve a mixture, a substance like salt or sugar to make a solution, if you evaporate the water, then you've turned it back into separate sugar and water instead of a solution. Or you've turned it back into separate salt and water instead of a solution. But then you could mix them again and turn it back into a solution. You can keep changing it back to its original state. Then we've got mixing. So we've got mixtures of all sorts of things. So we could, for example, mix together some sand and some stones. But then we can separate them again. So again, we're back to how they were originally, separate sand, separate stones. So dissolving and mixing. So all together, we have got melting, freezing, condensing, evaporating, mixing and dissolving. Whenever we make changes by melting, freezing, condensing, evaporating, mixing or dissolving, we should be able to change the substances back to how they were originally. Now the opposite of this is irreversible changes. This means that once you change something, you cannot change it back. And so this change now is permanent, forever. There's nothing you can do about it. It's an irreversible change. And that usually means that a new material has been made. So from your two original materials, you have created a new material. So one example is burning. So if you were to burn some wood or some paper, you will get ash. You won't have any wood after you've burnt it, you'll have ash, ceniza. The same with paper. We can burn other fuels to make energy, things like oil as well. Once that oil is burnt, we can't get the oil back. Once the wood is burnt, we can't get the wood back. It's an irreversible change. The change is permanent. There's no way you can take some ash and turn it back into wood. And with melting, for example, if you then cooled it, the melted chocolate, you turn it back into solid chocolate. But if you cool ash, you're not going to turn it back into a piece of wood. It's an irreversible change. You cannot change it back. That change is forever. Heating and cooking, this is one that you will understand because you see this happening every day. When you cook something or bake it and it changes, like an egg, for example. So when you crack open a raw egg, it's all liquidy inside. You cook that egg, you fry it or you boil it, then it solidifies, it turns into a solid egg. There is nothing you can do now to change that solid egg back into a runny, liquidy egg. You've heated it or cooked it to make it solid. You can't put it in the fridge and then suddenly expect the egg to be all liquidy and runny again. There's nothing you can do to change it back to its original state. That change is irreversible. You cannot change it back. Another example is rusting. This is one that some people find confusing because you leave some iron out in the air and the oxygen will react with the iron and any kind of water vapor that's in the air will make the iron rust. Sometimes we paint it or coat it with a special varnish to protect it, to stop it rusting. But if the iron hasn't been protected in any way and it's left in the open air where oxygen and water can get at it, it will rust. It will oxidize. Now, that rust is actually the iron has changed into rust. Some people think that if you brush off the rust, then you've returned the nail to its original state. But you haven't, because the rust is some of the iron that you can never change back. You can clean it off, but that iron now is lost forever. It's now turned into rust. It's irreversible. And our final example of an irreversible change is some mixtures create a chemical change. So the example given here is if you mix some vinegar with bicarbonate of soda, which is the stuff that you put in cakes to make them puff up in the oven, to help them rise, to make them all light and fluffy. So if you mix vinegar, which is an acidic liquid, with bicarbonate of soda, you get a chemical reaction. You get bubbles forming. Those bubbles are actually carbon dioxide. There's no bubbles in bicarbonate of soda. There's no bubbles in vinegar. But when you mix these two together, they make a new material. They make carbon dioxide gas. And there's nothing you can do once that gas has been created, that new material. You can't catch the gas and turn it back into bicarbonate of soda, or catch those gas bubbles and turn them back into vinegar. It's an irreversible change. It's permanent. You can't turn it back. So for irreversible changes, we have burning, like the wood and paper, cooking, like cakes and bread, and even clay. If you've ever made anything with clay in school and left it to go hard, maybe you've made models and things and left them to dry in the heat, then they go hard and solid. There is nothing you can then do to turn that solid clay that's become a pot or a model or something that's hard, you can't do anything to turn it back into liquid clay. Rusting metal, like we talked about the iron nails, that rust is the iron has changed into rust, you cannot change it back into iron. And then some chemical reactions where you mix two substances and create a new material. Now, all these are new materials. Burning creates, if you burn wood, you create ash. If you bake some dough, you make a new material, you make bread. Or if you mix together butter, sugar, flour and eggs, and you cook it, you make a cake, a new material. There's nothing you can do to that cake. You can't put it in the fridge and then suddenly it all separates and turns back into flour, sugar, eggs. That cake is a cake permanently. So, time for your quiz after that. You will go back and read through this carefully again. Look at the pictures to remind yourselves. Look especially at the summary at the end of each section. So all these are reversible: melting, freezing, condensing, evaporating, mixing and dissolving. All those changes you can change back. The second group are the irreversible changes. So look at your summary again. If you burn, bake or cook, rust something, or there's a chemical reaction, these are irreversible changes. Right, once you've been through all that information, you've got a little quiz here of 10 questions. It's a picture, a little sentence. If you freeze water and turn it into ice, is it a reversible change or an irreversible change? If you turn water into ice, can you turn it back into water? Is it reversible? Or is there nothing can you do? Is it ice forever? Is it irreversible? Here we have a cake mixture. So here we've got our batter made of the flour, sugar, eggs, whatever else you add in. If you put that in the oven to cook, is this a reversible change? Can you turn it back later on into separate flour, sugar and eggs? Or is it irreversible? It stays like a cake forever now, once it's been cooked. Right, I have tried to help you here by putting the keywords cook in capital letters, freeze. So if you're not sure, you can always go back. Look, cook. It's on the irreversible list. The word freeze, freezing is here, is on the reversible changes. So look for the keywords. Think carefully about, is it a change that you can reverse, that you can change back, or is it irreversible, a change forever and ever, permanent? So we've got some yogurt ice cream, a fried egg, some dough to make bread, evaporating water boiling away, some clay to make a pot, some burnt matches, some melted chocolate, and some rusted metal. So you've got to decide whether those changes are reversible or irreversible. There are 10 altogether. Now here at the end of the quiz, I've included a little video. I'm not going to play it now, but a little video that you can watch of somebody making a mixture which has a reaction. So it's a mixture of Coke and Mentos, which are sort of minty sweet. All right, now watch the video, but do not do this without your parents' permission because it's messy. And I would be amazed if any of your parents would let you do it if you don't have any outside space. Because what happens when you mix Coke and Mentos? Well, you'll see when you watch the video. A reaction takes place. A big reaction. You'll see when you watch the video. But no new material has been made. Nothing new has been created. Apart from a mess, but I don't think that counts as a substance. So do you think this reaction is irreversible or an irreversible change. I'm hoping to do this, and I think the other teachers are as well, in one of our video calls so you can see it in action even if you don't have a chance to do it yourselves. Okay, but maybe now that we can all go outside, even if you don't have a garden or a big terrace, maybe with a small bottle of Coke instead of a large bottle, maybe some of you will be able to have a go. Anyway, I hope you understand all the information well enough to work out whether each change is a reversible or an irreversible change. And if you do get a chance to do the fun experiment, enjoy yourselves, but don't get too much mess all over the place. Okay? See you later. Bye.